Alright, hello math people. Alright, today we're going to look at graphing a polynomial function, or more specifically, we're going to sketch it. So that means we can be a little bit less accurate and just worry about finding the roots. So let's look at a function like this one, and let's see what we can do with it first. We know that the leading coefficient is negative and that the degree is 4, so we know the shape is going to be something like that. And notice the constant is 0, which means we already know the y-intercept, it's also 0. It's because there's no number at the end, there's x's and everything. So first thing I'm going to do is factor out all the negative x's. It leaves me with a cubic function inside the brackets. And we also know now that there must be a root at x equals 0, which makes sense if we know the y-intercept. Now, I'm going to introduce a new idea. We're going to see later on in a couple sections. We try to guess at some of these roots. So 3 or 1 plus or minus might be a good guess to see if it goes into that 9. So what you do is you put x equals 1 into that function. So I'm just choosing 1. I could have chosen -1 or 3 or -3, but 1 is usually a good one to start with. Now when we plug it in, it turns out that it ends up equaling 0. So what that means is that p of 1 equals 0, which means that x equals 1 is a root because you must be on the x-axis. We also know then that x minus 1 is a factor. So what this is a good starting point to find the other roots, and this is where synthetic division or log division comes in. I'm going to jump right into synthetic just to avoid the long steps of polynomial log division. Okay. So we draw our little synthetic division box. And what we do is we take that root that we know is a root and we put it on the left side, and we put all the coefficients of the cubic function that we're trying to break down in the box. Right? You bring the 1 down and then you multiply it. 1 times 1 is 1, and then you have to add those numbers. 5 plus 1 is 6. Then we do it again. We go 1 times 6 is 6, add to get 9. 1 times 9 is 9, you add to get 0. What it does is you've broken it down into a quadratic. So if we piece it all together, notice I changed y to p of x, because this is a polynomial. It's just like f of x. We can say we know x minus 1 is a factor there. Now we know that this quadratic is sort of another factor of this polynomial. And thankfully, that's a perfect square trinomial. It's going to factor into x plus 3, which means we've got a double root at x equals -3. So I'm going to clean up the screen a little bit. I'm just going to rewrite that, that function. What we say now, we've got it in factored form. So this is called the factored form of the polynomial. It helps to find our roots. If we do a little sketch, we know our roots are at 0 and 1, and then there's a double root at -3, or we can say that there's a multiplicity of 2 at that root. So when we draw our graph, we just have to sort of bounce off the function there, off the axis, and it should look something like that. I'm going to check it on Wolfram Alpha by typing in the original function, and we see that it looks pretty close to what we've got, and we're done. Alright, more to come in the next video. Thanks for watching.